An important feature of Angular, which you typically don't interact with directly, is Angular's change detection mechanism. And in this section, we'll take a closer look at that mechanism and we'll explore what exactly that change detection thing is all about, how it works internally, how we can optimize it, at least potentially, with something that's called the on push strategy. And we'll also explore how change detection changes, no pun intended, when we start using signals, and how it's all related to this thing called Zone.js and how we might even be able to get rid of Zone.js in certain circumstances. So lots of topics that we'll cover in this section, and due to the topic, this will also be a theory-heavy section. We'll not build a real application here. Instead, we'll work on some dummy application, which I prepared and which you find attached, which allows me to highlight and explain and show all these different change detection mechanisms you should be aware of as an Angular developer. Because the thing with change detection is that it happens automatically behind the scenes, and you don't need to do anything to get and use this feature, but you can do something to improve how Angular performs change detection. And that's why we'll dive a bit deeper into this topic in this section here. Now, as mentioned in the previous lecture, I prepared a dummy project which allows me to explore how change detection works together with you. And you find it attached. And as always, you should run npm install to install all the dependencies, and then npm start to start this development server. And in this demo application which I prepared, you'll find a bunch of components that work together and that also exchange data, at least to some extent, so that overall you get this application where you got a counter that can be changed with help of these buttons here, where you got this message box where you can enter something so that test messages are added down here. And you see some dummy log messages on the screen, which will become important throughout this section. Most importantly, if you open your developer tools, your browser developer tools, you'll see lots of logs here. And these logs are, in the end, output by these components with help of some getter properties I set up here. And I'll explain why exactly I have them here later. But these logs mainly exist so that we can see when a certain component and its template is being evaluated by Angular's change detection mechanism. And as you can tell, if you look at this log, there's a lot of change detection activity going on. So therefore, let's now dive into this project and let's explore how change detection works in Angular and how we can potentially control and optimize it. So how does Angular's change detection mechanism work by default? Well, by default, you have your component tree, and Angular wraps that entire tree. In the end, it wraps your entire application with a so-called zone, which is a feature that's provided by Zone.js, an extra library that's maintained by the Angular team and that's heavily used by Angular, since it's that Zone.js library and that zone wrapper that's being set up that informs Angular about potential events that are going on the page that could potentially lead to changes that should be reflected on the screen, therefore. For example, if a user clicks a button, Angular gets notified about that, and then its change detection process starts and visits all components in the entire application, no matter where that click occurred. It visits all components in the entire application and takes a look at all the templates there and all the template bindings. So all the uses of property binding and string interpolation and so on, And Angular checks whether that binding now produces a new value, if it produces a value that's different from what was visible before. And if that's the case, Angular updates the real DOM with that new value. That's how change detection works by default in Angular applications. And that's why in this application, if we reload it and clear this log, if I click this one button, this increment button here, we get lots of log messages. Because I essentially get one log message from every component, because all components and their templates are revisited. And as I mentioned, all the template bindings are re-evaluated. And that's why I added this debug output getter to all my components, so that in the templates of those components, I can use that getter property, debug output, which will be re-evaluated since it's used with string interpolation, and therefore I'm using a template binding feature here. And as I just explained, Angular visits and checks all template bindings when its change detection process runs. So therefore the getter function gets executed whenever Angular evaluates that template binding, and therefore I can log that message here. So that in the end I get one log message per evaluated template binding. Though I'm of course only logging template binding checks for this debug output property, not for any other bindings. But still, we can see that we got a lot of logs, and most importantly, we can see that all components are visited and checked, even components that have nothing to do with the counter. Because keep in mind, I'm just changing the counter. Nonetheless, a lot of other components are visited as well. Now, this might sound like a big problem, and it theoretically could be if you're doing some performance-intensive work in your template bindings, but that is therefore also something you should avoid as an Angular developer. You should not have getters that perform super complex tasks, for example, because they get executed a lot. So if you're doing something performance-wise expensive in there, that's bad. If you adhere to that rule, it's actually no problem, or at least not necessarily a problem, that Angular performs a lot of checks, because Angular is built such that it does that very efficiently. Nonetheless, you will learn later that you can get rid of some of these checks and that you can put some optimizations into place. Before we do that though, and before we take a look at alternative change detection strategies, I want to clarify something else. Because if you take a closer look at the log output here, you might notice that it's actually the same log being output twice. All these components are visited twice. And that's a bit weird, because one check makes sense. But why does Angular perform two checks here? So why do we have this duplicate log output here? Why are all these components visited twice after our changes? So when I change the counter, for example. Well, that only happens during development. If you were to build this application for production and deploy it, you would not have this behavior. Instead, this is a development mode feature provided by Angular, because in development mode, it runs change detection twice to detect unwanted value changes that might happen after change detection was executed. That's why it executes it twice, to see if the value produced by the first cycle then suddenly changed. And an example for such an unwanted change would be, for example, in the info message component, if in the debug output you would return a random value. This value, since it's random, is not stable and will not be the same between two change detection cycles. Instead, a new random value will be generated on every change detection run, and therefore, if Angular performs two change detection cycles directly after each other, it'll be two different values that will be detected. and that will cause an error, as you see. If you reload, you get an error, and if you now change the counter, you also get an error. You get an expression changed after it has been checked error, which is Angular's way of telling you that the value that was found during the second development mode only change detection cycle is different from the value that was found in the first cycle. It actually even tells you that here in the error message. And therefore, if you happen to encounter an error like this in your Angular application, it is likely that somewhere in the application, probably in the place that's highlighted here, you have code that changes data that's being shown on the screen in an unintended way, and that you have a potential bug in your code. That's why here I'll go back to that fixed string, which of course is stable and won't change between cycles. So that's where this error is coming from and why during development Angular runs change detection twice. But now let's take a look at how we can potentially optimize Angular's change detection behavior.